We want to evaluate the triple integral over the region E, where the region E is defined here, where y is greater than or equal to -2 and less than or equal to 0, x is greater than or equal to 0 and less than or equal to y, and z is greater than or equal to 0 and less than or equal to x plus y squared. Let's first look at the region E in space. So again, the region E is the region bounded by y equals 0 and y equals -2, which are the two planes graphed here in yellow, as well as x equals 0 and y equals x, which are graphed here in light blue, and then also bounded by z equals 0, which is the xy plane, graphed here in dark blue, as well as the surface given by z equals x plus y squared, also graphed here in blue. So the region of integration is this solid region here. So going back to our work, notice how z is defined in terms of x and y, x is defined in terms of y, and y is defined in terms of constants, which means we'll use the order of integration given by dz, dx, dy. So we have the given triple integral, where the integrand function is x plus y minus 4z, and then again for differential v, we're going to use dz, dx, dy. And again, the reason we're using this order of integration is because z must be defined in terms of x and y, which it is here. X must be defined in terms of y, which it is here. And finally, y would be defined in terms of constants, which it is here. Which means the limits of integration for z are going to be from 0 to x plus y squared. The limits of integration for x are going to be from 0 to y. And the limits of integration for y are going to be from -2 to 0. And now we first integrate with respect to z, treating x and y as constants. So the antiderivative is going to be xz plus yz. And then we're going to have -4 times z to the second divided by 2, which simplifies to -2z squared, or minus 2z squared. And now we need to find big F of b minus big F of a by performing substitution for z. So for big F of b, we're going to have x times the quantity x plus y squared plus y times the quantity x plus y squared, and then minus 2 times the quantity x plus y squared raised to the second. So all this is big F of b, and then minus, when z is equal to 0, notice each term does have a factor of 0, so we're just going to have minus 0. And now we'll go ahead and simplify here. So here we'll distribute x, so we have x squared plus xy squared. Here we'll distribute y, so we have plus xy plus y cubed. Now here we're first going to square the quantity x plus y squared, which would be x squared plus 2xy squared plus y to the fourth. Then we would distribute the -2, which would give us minus 2x squared minus 4xy squared, and then minus 2y to the fourth. And now we'll simplify here by combining like terms. So we have 2x squared terms. We also have 2xy squared terms. So the simplified integrand function is going to be -x squared, and then minus 3xy squared, and the other terms remain the same, so we have plus xy plus y cubed minus 2y to the fourth. And now we integrate this back to x, treating y as a constant. So the antiderivative of the first term is going to be -x to the third divided by 3, or -1/3 x to the third. And then we'll have minus 3y squared times x squared divided by 2, or minus 3/2 x squared y squared, plus x squared divided by 2 times y, or 1/2 x squared y, plus xy cubed, and then minus 2xy to the fourth. And now we need to find big F of b minus big F of a by performing substitution for x. So when x is equal to y, we would have negative 1/3 y cubed minus, again, when x is equal to y here, we're going to have minus 3/2 y to the fourth, plus here we'd have 1/2 y to the third, plus here we'd have y to the fourth, and finally here we'll have minus 2 y to the fifth. And then when x is 0, notice all the terms contain a factor of 0, so we just have minus 0. And once again, we'll simplify the integrand function by combining like terms. We have 2y cubed terms, as well as 2y to the fourth terms. Negative 1/3 y cubed plus 1/2 y cubed is equal to 1/6 y cubed. And then we have negative 3/2 y to the fourth plus 1 y to the fourth, which is negative 1/2 y to the fourth, or minus 1/2 y to the fourth, and then we still have minus 2 y to the fifth. And now we integrate with respect to y. So here we're going to have 1/6 times y to the fourth divided by 4, which is 1/24 y to the fourth. Here we'll have negative 1/2 times y to the fifth divided by 5, or minus 1/10 y to the fifth. And finally here we'll have negative 2 times y to the sixth divided by 6, which should be negative 2/6, or negative 1/3, or minus 1/3 y to the sixth. When y equals 0, notice how each term contains a factor of y, so we're just going to have 0 minus, when y is equal to negative 2, we'll have 1/24 times negative 2 to the fourth minus 1/10 times negative 2 to the fifth minus 1/3 times negative 2 to the sixth, which simplifies to 262/15. Or as a decimal approximation, this is approximately 17.4667. I hope you found this helpful.